Okay, and there could be other chance. If you are not improving it, how we have calculated error? See, I'm just giving you one example. Okay, someone might have gone and checked it. That's true. Your point is correct. There, see, for example, there might be some blurry images. Someone might have gone and checked it, and then only they have identified the error. But here I am giving you an example. I'm not telling you that someone would go and check it. I'm just giving you an example. Okay. So see, with this data set, you will split your data set, right? You will split this data set into training and test data sets, say 80% and 20%. Now imagine these blurry images, side view images are also there in training data set and test data set. So when you build the model, machine learning model, when human is not able to identify that by looking at the image, see, by going back and looking at the car, they might be able to come up with. That's different story. But what we are doing, we are not doing anything manually. Here, what we are doing is we want to automate things, right? That's the reason we are using machine learning. So when human has some error, machine learning will also have that error in the training data set and test data set. So imagine that your human error is 3% and your training error and your test error, which you are calculating from machine learning, say I have a data set here which have a 3% error by doing a classification manually, but you can correct it going back and then you can check it. You can correct it, but that's a different story. But here the aim is when a human classifies that manually just by looking at the images, we are getting 3% error. Let's assume someone has calculated that. Okay, because that is something which has to be done manually. Now for training error, let's say that you got 4% error, and then in the test data you got say 15% error. What does it mean, guys? It's simple, no? Your machine learning model is not able to generalize from training to test data set. Yeah, it's not failed, it's not able to generalize. Okay, it's predicting, right, with 85%. Okay, no problem. So what we are trying to tell here is this is called as overfitting issue. Okay, you have fitted your model so well for training data set that it was not able to predict properly for test data set. Now you must be thinking why it is happening. Say when you have splitted your data into training and test data set, imagine that all the blurry images are sampled into test data set. Imagine, it could be possible, right? Because it is simple random sampling. Most of the blurry images are gone into this. So it is classified incorrectly. That's the reason you have got a bad accuracy for test. So this is called as overfitting issue. Now, say your human bias error is say 3%. Now your training data set is 15% and your test data set is 16%. Now you're having a lot of blurry images in training data set and your machine is not able, your algorithm, say decision tree, your decision tree is not able to classify this correctly with more than 85% of accuracy. Then your algorithm is not behaving properly for training data set itself, then how can you expect it for test data set? So this is called as underfitting issue. Now let's say your human bias error is say 3%, your training error is say 15%, your test error is say 30%. Then it is over and under both, right? Under and over both, because your algorithm is not able to capture such minute details for the training dataset itself. Now your human bias error is say 3%, your training error is say 3.2%, your test error is say 3.5%. Now tell me, this is the best solution, right? So in reality, how do we calculate that human bias error? In reality, you will not be provided with this human bias error in your projects. So what you should do? You should try to minimize your training error, and then you should test it over test data, and then your test error should also be minimum and very near to your training error. Did you understand this? The training error and the test error should be minimum as much as possible, but both should be equal to very near to each other. Then it is called your algorithm is the best algorithm or the right algorithm or the apt solution. Now remember this. This overfitting issue, sometimes people will call this as variance issue. Underfitting issue is called as bias issue. And underfitting and overfitting both is called as bias and variance issue both. Okay. Now I'll give you one example. Tell me, I have performed a linear regression. I got the mean square error as 1% for training data set, and for test data set I got say 10%. What issue is this? Variance or bias? This is very, very, very rare. I think it's, to best of my knowledge, it can only happen when you have very simple data sets. But it's very rare. I have never seen. It can be more or less equal. Your tested error can be equal to your training error, but it cannot be lesser than your training error. I have never seen any such scenario. Because imagine that your algorithm is building on your training data set, right? If you are having a training error, then how can that algorithm performs or beats your training error? It's very rare. I've never noticed that. Training error and test error I've seen equal once for very simple data, but I've never seen that test error beating training error. So tell me, what is this issue? Variance or bias? Right. Now let me give you one more issue. What is this now? Underfitting or bias? Now, this would be confusing, guys. This would be really confusing how we say that this is the minimum error that we can achieve. So for that, you have to apply different algorithms. You have to try standardizing your models. You have to try different combinations of 80, 20, 70, 30, 90, 10. And then only you can tell whether it is underfitting issue or not. Okay. But by looking at this 10% and 11%, I am thinking that this could be underfitting, but it depends. When you do a lot of analysis, when you run different algorithms on the same data set, when you do training test split as 70, 30, 80, 20, 90, 10, something like that. You have to do a lot of trial and error, and then only you will come to know what could be the minimum error that can be achieved. And then based on minimum error, you can benchmark that error, and then you can tell for the different algorithms that these algorithms are behaving underfitting or overfitting. Okay. So overfitting is very simple, but underfitting requires to understand whether the model is underfitting or not. we have to do a lot of analysis. Okay. Now, how can be a same case be over and underfitting? Okay, let me give you this. Let's say that in machine learning language, we have noticed that neural network is the best algorithm. Okay. We have not learned that. I'm just giving you example here. So let's assume that in this, you have got a training error as say 2% and your test error say you got 3%. You have performed random forest here. You got 2% as training and 8% as test. Now you perform very basic logistic regression. You got 10% here and 15% here. Now in this case, this logistic regression model is not able to train your data set in a way it is supposed to. So in this case, this model is behaving both underfitting and overfitting. This model is behaving it as only overfitting. And this is a just right solution. So that's what I'm saying. To understand whether a model is underfitting, you have to perform a lot of different algorithms on the same data set. Otherwise, you cannot benchmark, right? Until and unless in the project they give you what is the human bias error, you cannot benchmark, right? Okay, so let's visualize this in a better way. Let's say I have a training data set. It's a multi-dimensional, okay? It's a multi-dimensional, guys, okay? And I'm just plotting the circles as one output class say 0 and triangles as 1. Okay, so let me take some other one. These are circles. Let's say this is for training data set, okay guys? This is for training data set. Now, I am coming up with one algorithm. So these circles are zeros, triangles are ones, okay? Which splits your training data sets like this. So it's a classifier model which classifies circles and triangles as 0 and 1s. So now if you notice, it is misclassifying for some of the zeros, right? If I try to make the algorithm better, now what I can do? So I'm trying to calibrate my algorithm in such a way that it classifies all the points correctly. But this has made your algorithm very complex, and then there will be a chances that it will not behave correctly for your test data set. So this is called as overfitting. You're fitting your model over. This is called as underfitting. I'm just giving you one example, guys. Okay. Now, let's say that I'm coming up with a graph, something like this. It has less curve when compared to this overfitting graph, but then there are some misclassifications here. So that's okay. So that is how we have to compromise with the accuracy and make sure that our model is just apt, so that it should not be overfitting or underfitting. Okay, this is just an example, guys. Okay, I'm not a very good drawer, but it is just an example which I'm trying to show you. how underfitting means and overfitting means and just apt means. Now, how to tackle this underfitting and overfitting, that you will come to know when you do project, okay? Or you can try with different algorithms to come up with the right solution, or you can try changing 70 to 30 to 80-20 or 90-10. But there are some more methods also. We'll be noticing that when we do the final project, because that is something which requires a lot of knowledge, and that you will get it at the end of this course. And then when you do final project, at that point of time you can try making your model overfitting, and then making it, bringing it back to the just right solution. Okay, you know how to make your model overfitting. Just train your model in such an efficient way that it doesn't behave correctly for test data set. Maybe 95% and 5% will make your model overfitting. It has more chances. Okay, so difference between decision tree and random forest, that you already know now. List down the advantages and disadvantages of random forest. You know what is the advantage? It is less prone to overfitting. But what are the disadvantages? You should tell me. One is that it might take more time. What are the other parameters to assess the classifier? So I think I have taught you some of the parameters here. Apart from these parameters, there are a lot of more different parameters such as F1 curves and other things which you can look into internet, and then you can answer this third question. What are the other parameters to assess the classifier? Now, this would be your first project, guys. Perform exploratory data analysis and all the different classifiers or the regression, whichever is required for the case study, and you can evaluate the performance. So for time being, what you can do only exploratory data analysis. That's okay. If you want to do this classifier or regression thing also, you can do it. Or if you do only exploratory data analysis also, that's fine. So what is exploratory data analysis? It is descriptive analytics, right? Do calculating mean, median, variance, skewness, kurtosis, and then plotting histogram, bar graph, like bar chart, different graphs, and then by looking at these values, trying to identify if there is any outlier or how different parameters are interrelated, and if this different columns, by looking at this descriptive analytics, are you able to come up with some recommendations, not doing any machine learning, just by doing exploratory data analysis. So it's only calculating mean, median, and then coming up with some insights. Okay, it can be anything, nothing will be wrong here. It's just that some insights you have to come up with, and based on the data you can tell whether you have to perform classification or regression. If in the data set you are not able to understand what is the output, then you can only perform exploratory data analysis also. Okay, now let's go back to coding. Again, same thing, NumPy, Pandas, Matplotlib. I didn't teach you how to calculate mean and variance, that you have to do it. Okay, okay, so we have created our pandas data frame. If you have to import your CSV, create your pandas data frame, and then as usual from Skill-Learn import model underscore selection, and then from that there is a function which is train underscore stress underscore split your data as you want. You can try 70-30, you can try 80-20, or you can also try different samples so that you can come up with the different accuracy values, and you can check whether it is underfitting or overfitting. So which samples would be better to go with training and which sample would be better to go with test. So you can try different things now. Now you have sufficient knowledge to play around with the data. Now, last time we have imported tree from sklearn for decision tree, but now we are importing ensemble. So your ensemble classifiers will be in ensemble. So again, assign this ensemble. In ensemble, you have a function by name random forest classifier. Assign that to what? One variable. Okay. But like till previously we were just putting empty arguments. Now you have to give some argument here, guys, because it is an ensemble method. You have to give some argument here. If you don't give, I believe it will take some random value. But then could you tell me what is this doing? I think you should be able to guess it now. What is this doing, guys? So with 40 trees, you're training your model.fit on the same training data set, and then finding the score on the test data set, predicting Y on X test, and then plotting your confusion matrix with the help of predicted output and the actual outputs. Okay, so now you must have understood it's a matter of only this one or two lines which will keep changing. So you must be thinking this Python is very simple, right? If you remember this kind of data like this flow, the Python would be very simple, right? But in reality, guys, if it is only a matter of only one or two lines, but then you have to do lot of exploratory data analysis. First thing. Second thing, your model will not be giving you just right solution. It might be underfitting or overfitting. You have to try different things. How do you try that? So now, in this case, you have to try with say 10, 15, 20 trees, 5 trees, 10 trees, 15, 16, 17, 20, 25, anything. And then find the score of training on the training data set and on the test data set. And then look at the accuracies with respect to different number of trees. Identify which could be a just right solution by looking at the accuracies. If the error should be less, that means accuracy should be more, right? So you have to come up with, here you have to write for loop now. You have to write for loop. Why? Because we have to keep changing this number of trees and store the accuracies in different variables so that we can analyze the solution in a better way, right? So machine learning is only one or two lines, but to have a structured thinking and implementing that on Python and having the results which could explain your client very easily, you should have some visualization techniques. So you have to plot graph here between your accuracy, and you can plot the graph of training data set, accuracy of training data set with number of trees, and test data set accuracy with number of trees. By looking at those two graphs, you will get the hint which could be the right model to choose or right number of trees to choose. Or also, if you know 3D graph, you can also draw that. So, but I always tell guys, please keep practicing on Python. Take the help of Google. You can always take the help of Google for any small syntaxes, because I also take the help of Google for syntaxes. I cannot remember. No one can remember the syntaxes. So it should not be a problem for remembering the syntaxes, because Google has all the syntaxes. It's just that your concept should be clear, because Google cannot tell you whether the model is overfitting or underfitting. That your concept will tell you whether the model is overfitting or underfitting. Google cannot give you the accuracy. You have to calculate the accuracy. Google cannot give you the precision. So I would say take the help of Google for syntax and try building up the model now. Just build the small algorithms, very small algorithms, importing the libraries. Second step, coming up with a Panda data frame, importing the CSV file. Third step, split the data. Fourth step, assign your model to some variable. Fifth step, fit your model and calculate the accuracies. Sixth step, calculate the predicted output and confusion matrix. If you can do this at this time of course till 9th or 10th session also, then you are good enough to go, guys. And then when you do final project, that will be a combination of different algorithms, and then you have to perform both exploratory data analytics and predictive analytics there. and then you have to give some recommendations also. So it will be a combination of descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So by end of this course, you would be able to understand how to deliver a data science project. Okay, guys? If you have any questions, we are planning to arrange a support session. Next week, I believe we will be planning to arrange one support session because we have completed half of the course. So now we should be able to arrange one support session. So please keep practicing so that in next support session, we can have a lot of question and answers. Okay, guys, thank you so much.